Welcome to Edupedia World Grade 10 Computer Science Video Lecture Series. I'm Upeka Vandibona, and this is the second part of numbering systems conversions. In the previous episode, we learned how to convert binary to decimal and decimal to binary. And from this episode, we are going to incorporate the other two numbering systems, octal and hexadecimal. We first start with the decimal to octal conversion. In octal numbering system, the base is 8. The values of the octal numbering system has the combinations of numbers 0 to 7. So when you count in the octal numbering system, starting from the 0, 1, 2, 3, 4, 5, 6, 7, there is no 8, there is no 9. After the 7, it starts the 10. Now this 10 is not the decimal 10, it is octal 10. So that's how the octal numbering system behaves. Now let's focus on the conversion of decimal to octal. Here we are given the number 125. It's a decimal value. We have to convert into an octal value. So for that, we have to divide it by the base of the octal numbering system. That is 8. So 125 divided by 8, the quotient is 15 and the remainder is 5. So this is the same process as we did in decimal to binary. The only difference is here we are using the number 8 rather than 2 for the division, because we need to obtain the value of octal numbering system. So here we take the quotient 15 and again divided it by 8. The quotient is 1 and the remainder is 7, and take the quotient 1, divided it by 8, then the quotient is 0 and the remainder is 1. So we stop in there and take the reminders in the reverse order, 175. So 175 is the octal representation of the decimal value 125. Okay, now the next thing is converting decimal fraction to an octal number. This is same as what we did in the previous episode, converting decimal fraction to a binary numbering system. Only the difference is here we are multiply it by 8, the base of the octal numbering system. Let's try to do that. Here we are given the 0.75 decimal fraction value. We have to convert into the octal numbering system. Okay, now the initial fraction value is 0.75. We have to multiply it by 8. The answer is 6.00. As the fraction value is now 0, we can stop right here. We take the integer part, it is 6. So the octal representation of the decimal fraction value 0.75 is 0.6. Okay, now here is the other side of the conversion, octal to decimal. Here we are given the octal number 321. Remember, this is not a decimal number. This is a octal number 321. We have to represent it in the decimal number format. Now, like as in the previous episode, as we did in binary to decimal, we had to create this table structure. But the difference is, in the first row, here we are representing 8 to the power of n. Rather than using the 2 to the power of n, here we are using 8 to the power of n. Starting from the rightmost position, 8 to the power of 0, 8 to the power of 1, 8 to the power of 2, and so on. In the second row, it shows the values of the first row. 8 to the power of 0 is 1, 8 to the power of 1 is 8, 8 to the power of 2 is 64. Now the third row represents our octal number value 3, 2, 1. The fourth row is the multiplication of the second row and the third row. 1 multiplied by 1 is 1, 8 multiplied by 2 is 16, 64 multiplied by 3 is 192. Now the last step is summing up the fourth row. 192 plus 16 plus 1 is 209. It is the decimal representation of the octal value 321. Okay, now the next thing in our agenda is converting octal fraction to a decimal number. We are given the number 23.25. It is an octal number. We have to convert it into a decimal number. So for that, we have to create that table structure. In the left side of the radix point, it represents the integer part. For the radix point, here we can also call it octal point. For the right side of the octal point, it represents the fraction part. In the first row of the fraction part, starting from the leftmost position, it shows 8 to the power of minus 1, 8 to the power of minus 2, and so on. In the second row of the fraction part, it shows the value. So the 8 to the power of minus 1 is 0.125, 8 to the power of minus 2 is 0.015625. In the third row, it shows the fraction number of the octal value, 25, and the fourth row, it is the multiplication value of the second row and the third row. Now the final step is summing up the fourth row. So 16 plus 3 plus 0.25 plus 0.078125 is equal to 19.328125. So this is the decimal representation of the octal value 23.25. Okay, now we have covered up everything regarding the decimal and the octal relationship. Now we are moving on to relationship of decimal and hexadecimal. So here we are learning how to convert decimal to hexadecimal. Before moving on, let me tell you a little thing about the hexadecimal. For the hexadecimal, the base is 16. It has the values 0 to 9 and A to F. When you're counting in the hexadecimal, starting from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Before starting 10, it has the values A, B, C, D, E, F, and then starts 10. Now this 10 is not the decimal 10, it is the hexadecimal 10. So that's how the hexadecimal numbering system behaves. Now let's move on to our activity, decimal to hexadecimal conversion. We are given the decimal number 300. We have to convert into the hexadecimal value. So for that, we have to divide it by the base of the hexadecimal numbering system, that is 16. 300 divided by 16, the quotient is 18 and the remainder is 12. Now in here, for the hexadecimal numbering system, 12 means character C. So rather than having the numbering value, we have to use the character value C. Now take the quotient 18 and divide it by 16. The quotient is 1 and the remainder is 2. Take the quotient 1, divide it by 16. The quotient is 0 and the remainder is 1. Now take the remainders in reverse order, 1, 2, C. So the answer is 1, 2, C. It is the hexadecimal representation of the decimal value 300. Now let's move on to converting decimal fraction to a hexadecimal value. Like as before, we are given the decimal value 0.75. We have to convert into a hexadecimal number. Take the fraction part of the given number 0.75, multiply it by the base of the hexadecimal numbering system, that is 16. So 0.75 multiplied by 16 is 12.0. As the fraction part is now 0, we can stop right there. Take the integer part 12. Now in the hexadecimal numbering system, 12 means the character C. Therefore, the hexadecimal representation of the decimal value 0.75 is 0.C. Good. Now the other side of the conversion, hexadecimal to decimal. Here we are given the hexadecimal value AB. We have to convert into the decimal number. Create that table structure. In the first row, starting from the rightmost position, 16 to the power of 0, 16 to the power of 1. In the second row, the value of the first row, 16 to the power of 0 is 1, 16 to the power of 1 is 16. In the third row is our hexadecimal value, AB. So here, rather than using the characters, let's mention the value of the character. So for A, it is 10. For B, it is 11. Fourth row is the multiplication row. 1 multiplied by 11 is 11. 16 multiplied by 10 is 160. Now the next step is summing up the fourth row. 160 plus 11. It is 171. So the decimal representation of the hexadecimal value AB is 171. Okay, now this is the final activity in decimal relationships. Conversion of hexadecimal fraction to decimal numbering system. We are given the hexadecimal fraction value IE.8c Now we have to convert into a decimal number. So for that we need this table structure. In this table structure you can see the radix point. We can also call this as hexadecimal point in here. In the left side of the hexadecimal point it represents the integer part. The right side of the hexadecimal point it represents the fractional part. Integer part is same as previously we did, but for the fractional part, starting from the leftmost position, it represents 16 to the power of minus 1, 16 to the power of minus 2, and so on. So in the second row for the fractional part, 16 to the power of minus 1 is 0.0625, 16 to the power of minus 2 is 0.003900625. Now in the third row, it have our hexadecimal value i.e. 0.8c. Now for the characters E and Z, rather than using the characters itself, we are going to show the value of those characters. For E it is 14, for the C it is 12. Now in the fourth row it is the multiplication of the second row and the third row. So 16 multiplied by 1 is 16, 14 multiplied by 1 it is 14, 8 multiplied by 0.0625 is 0.5, 12 multiplied by 0.003900625 is 0.046875. Now the final step is summing up the fourth row. 16 plus 14 plus 0.5 plus 0.046875 equals to 30.546875. So it is the decimal value of the hexadecimal value i.e. 0.8c. So with that we are going to wind up this session and continue to the next episode of part 3. So up to now we have covered up every relationship the decimal numbering system have. Decimal to binary, decimal to octal, decimal to hexadecimal, and vice versa of each of them. From the next episode we are talking about the other type of relationships the binary, octal, and hexadecimal numbering systems have. So thank you for watching and stay tuned on with Edupedia World.